Hello everyone. Today we are going to work on this landscape material which automatically change the color of the landscape based on the slope of the ground. So I have removed all the textures and all other parameters and just kept the color only to keep the material simple. So later on we will of course integrate the textures and everything, but for now we only need to understand how to change the layers based on the slope. So I only want to focus on that, so that's why only simple colors are here. So roughly these black faces are like rock surfaces and these are like soil surfaces that are next to the rocks, and then grass layer. So right, and also if you make any changes to the landscape, you can see the painting happens, it automatically adjusts the color as well. So right, so let's see how to implement this material today. Alright, so here is the landscape without that material, without any material. So this is just the default material. So let's create a new material, M and K bottom. Yeah, M landscape. Alright, now I'll select this material and assign it to the landscape, to these streaming components. So yeah, still it looks same because I haven't implemented anything here. Right, now I'll create a vector parameter. I'll call it layer 1. It's just a color, and I'll change it to green basically. Now you see everywhere is green. Well, it's a bit too sharp. Right, now we have only one layer. Okay, so let's first look into how to have two layers based on the slope of the ground. So to get the slope of the ground, we can use this vertex normal world space input. So if I directly connect it, no need to connect. If I preview this, this is what we see. Alright, now if I do a dot product between this vector and up vector, so I define a constant 3 vector, and to make it the up vector I'll keep x and y 0, z 1. And when I do a dot product, if I start previewing this one, this is what we get. So a dot product means, so this is the definition. The dot product measures how closely two vectors align. That's basically the what we get from a dot product. So To further explain it, if I have a surface like this and the normals are from this surface, normals are extending outwards from the center. So in here, normals are like this at this point, and in this point, normal is like this, and at this point, the normal is like this. So outward from the center of this curve of the surface. So up vector is basically a vertical vector. And how closely? If we consider this vector and this vector, so both are vertical. That means the dot product is 1. So because they perfectly aligns. And these are this vertex and this vertex don't align that much, so the dot product becomes something less than 1, so something in between 0 and 1. Similarly, at this point, this vector and this vector, the dot product becomes 0 and then negative. It goes to negative. So that's why when we preview this, here we have white, that means 1, and after this point it becomes black, that means it goes to minus region, and here we have a shade of white, so that means it changing from black to white, that means changing from 0 to 1. Alright, so if I use this one as the color of the ground, this is what we get. Basically, the flat area is white and the angled areas are somewhat black, but still remains in the white region. That's because they are not the angle is not higher than 90 degrees in this landscape, so that's why they still stay in like a shade of white. So if I want to move this black region upward, what we can do is after this dot product we can add an offset. So I'll name this, let's promote this to a parameter, layer 1 offset. Okay, and if I connect here, it still remains the same, but let me set the slider max to 1, and here if I change the value, it doesn't change. Sorry, it doesn't change because we are previewing this one. Let me stop previewing this one. Now we see the total output of this material. So now as I change this, you can see how this value changes. So if I make it 1, it becomes completely white except the lower part, and if I make it -1, it becomes completely black. So if we need to move the black area upward, we need to give a negative value, something like -0.6. See, so this is the area we get, this is the color we get. So now you see these surfaces has become black and the other region remains white. Now you see this area, so this gray area, so it's not a sharp edge, right? So that's why this is smoothly changing from white to black over a certain range. So if you want to make this edge sharper, what you can do is we can add a not multiplier, can add a power node. So here if power is 1, we have some sharpness. If the power becomes larger than 1, the sharpness becomes much lower. But if it is 0, it becomes very sharp. So I'm not sure what happens. Oh, minus things actually doesn't make sense for power. Oh, it does, but yeah, I don't think the sharpness increases more than this value. So if I make it like 0.3, so you can see as this value becomes lower, the sharpness increases. See, so at 1 we have this sharpness. It's a bit blurred, but I think I like something like this. Okay, alright, now we have wait, let's promote this to a meaningful parameter. So as you can see, when this becomes closer to 0, the sharpness increases. When it becomes higher, sharpness decreases. So let's have a not to subtract, let's have a divider and promote this value as the layer 1 sharpness, and we should not have 0 here. Maximum value, let's say 10, minimum value 0.1, default value 0.1, no, default value should be 1. Okay, now you can change it. When the sharpness increases, it becomes sharper. When the sharpness decreases, it becomes blurred. So let's keep something like 1.5, like this. Right. Okay, now we have 2 layers. Okay, but the color is completely based on this calculation. So if we need to have 2 colors, let me duplicate this material and I'll name this one as layer 2. So layer 1 I'll change to black, and I'll keep layer 2 as green, and let's do a lerp. That means linear interpolation using this value as the alpha, and connect it to the base color. So this is what you get. Now you get rock surface and the grass surface basically. So layer 1 and layer 2. Okay, now we have 2 layers. Now how can we have another layer? So for that, basically we will have to do this same calculation with different offsets. So how can we reuse this piece of code? So we can't actually convert this to a function just like in blueprint. So here I'll add a new material function. So these materials are also like programming, so we should, whenever we possible, we should make functions, whenever we make parameters, so we should reuse the code, so it makes things much simpler and easier to understand. So material function, mf layer blended. Okay, now I'll copy this part, mf layer blending in here, and connect the result here and apply. Okay, now here I'll add a function input, not a vector3, scalar, and I'll name it in offset. Well, I don't think in is required. Offset or layer offset, and another parameter, layer sharpness. Alright, so as the default value, can I define a default value? I can't. But we can define a preview value. I'll use this same value, minus 0.6. $1.8. or 1, doesn't matter. And instead of these values, I'll use these inputs, function inputs. Okay, now I'll get rid of those two functions. Okay, now we have a function that returns the same calculation as we have done here. So now let me move this to here, and mf layer blending, let's drag and drop it here. Now I have layer sharpness and layer offset, two parameters, right? So we can layer 1 offset, connect here, layer 1 sharpness, connect here, and the result goes here. So we still have the same output. Now we can get rid of this part. Cool. Now the function looks much simpler, the material looks much simpler. So right, okay, now if we need to have a third layer, so now this is where this becomes useful. If I need to have a third layer, I can duplicate this setup, and here I'll rename this parameter as layer 2 sharpness, and this one layer 2 offset. Okay, now obviously we need different offsets and sharpnesses for these, for the next layer, otherwise we wouldn't see that. So basically we need an offset above this line, so that depends on how we are going to blend these two layers. So let me preview this. So here we have the limit of this layer. If I change the offset to 0.7, it goes up like this. Right, now I'll have a third layer. I was pressing Ctrl D to duplicate and rename layer 3. Color, so this is going to be like the soil layer, so some brownish color, and do another layer. This is the other input. Oh, wait a minute, I think it has to interchange, but let me stop the preview. So here we have brown and then green. Actually that has to be changed, so this should go up and this should go second. No, that doesn't look correct either. Alright, okay, actually this is correct. We just have to interchange these colors. So layer 1 is this one, this is layer 2, and this is layer 3. So for the third layer should actually become green in order to make it look like the grass. So okay, second layer should be brown. Now it looks correct, and if I apply, now we have 3 layers. See? Okay, so now if we want to change the parameters here, so that I can see. So if we want to increase the brown area, what I need to do is the layer 2 offset. Slide them in. I got -1. See? Now it becomes more brown. Okay, and if I want to increase the sharpness, because this area is somewhat also brown, so if I want to increase the sharpness, we can increase this value. See? Out. Alright, now that's, is this enough? Maybe we need a bit more offset. Yeah, this seems okay. Alright, and now if we need to have more rock surface, we can simply, here wait, set them in. Why it doesn't go below 0? It doesn't matter. 0.8 too much. -0.7. Okay, so yeah, now we have the parameters. You can change according to your taste, right? Okay, so now here we have two layers, and I'm gonna stop this episode right here. Sorry, not two layers, three layers. So we have the rock layer, and then soil layer, and then the grass layer, right? So thanks for watching. As always, project files will be available for the download in the Patreon page. Link would be in the description below. And if you like to support my work, you can get the membership of the Patreon club. See you in another episode. Goodbye.